Malaria is a mosquito-borne infectious disease affecting both humans and animals. The disease is widespread in tropical and subtropical regions with a high concentration in sub-Saharan Africa. According to WHO, in 2017, 219 million cases of malaria occurred worldwide, resulting in 435,000 deaths. Undoubtedly, malaria imposes substantial costs to both individuals and governments. Hence, it's important to find a cheaper anti-malaria drug.
Prior to the final purification of our product, we carried out these reaction schemes, converting our triazolopyrazine core to our unique anti-malarial drug.
Liquid-liquid extraction is a basic analytical technique that separates two immiscible liquids, typically an aqueous and organic solvent. The organic layer tends to be on top due to its lower density. A separating funnel is used for this process.
Here we are separating the lower aqueous layer and removing the top organic layer into a flask. This is then added into a separating funnel again, along with some sodium chloride. The sodium chloride removes impurities and any potential leftover reagents. After the salt is added, it is important to mix the contents and the stopcock is twisted in order to let the pressure out. Here we are allowing the two layers to sit, with the salt layer forming at the bottom with any impurities. The salt layer is then removed and the rest of the organic solvent with the product inside is left in the flask.
Then magnesium sulfate is added, which acts as a dehydrating agent, removing water from the final product. Then the content in the flask is mixed and it is filtered to remove the magnesium sulfate. Now a rotary evaporator is used to remove ethyl acetate solvent by evaporation under reduced pressure, leaving the final product in the flask.
Once we purified our product, it was important to check whether we had actually made the right drug. Here, we are transferring our substance into an NMR tube, which will then be used to test our sample. This is the NMR spectroscopy machine which will test our sample. When it is running, it creates an extremely strong magnetic field, which meant we had to take many precautions while using it. These are the results we got from the NMR machine. Although they look very complicated, it is relatively easy to interpret. Each peak corresponds to a specific group of identical hydrogen atoms which are found in our product. For example, this large peak most likely corresponds to this group of hydrogen atoms on our drug. However, it is important to note that many of these peaks could be from impurities in our sample.